Hey, it's Mayor from Chat with Data, and today we're going to be talking about how do you chat with multiple massive PDF documents across multiple files. Say, in this case, we're looking at Tesla, and we're looking at annual reports for 2022, 2021, 2020, and each year the PDF files are huge. Like here's 2022 is 449, and then 2021 is around 300, and you add it up, you're looking at about 1,000 pages of PDFs, and it just goes on and on and on, and just financial reports and all that kind of stuff. Extremely tedious to go through and read. And what we want is a situation like this where you got Warren Buffett asking you what you like to analyze, but we can ask a question about specific PDF. So what were the risk factors for Tesla 2022? And so it starts searching, and it's going to give us a response. So it's talking about cyclical industry, inflationary pressures, increase in interest rates, the pandemic. And what we want to do now is cross-check, because it's going to give us a reference, and it points to page 33. Let's go to page 33 here. Oops. And let's see. We are focused on growing manufacturing, demand and sales, energy regeneration, and let's see. Is this about risks? Okay, so it covers the highlights. So more or less, it's kind of looking at this section that has the management discussion, and is able to kind of assess the risk factors from there. But what if we don't just want to talk to one PDF? I mean, talking to one PDF is already insane, right? That was a 500-page PDF document. But what if we wanted to talk to three of them simultaneously over the past 3 years and ask a question that analyzes the past 3 years? So how have management performed over the past 3 years? And let's see. Now this is where it gets interesting, and it picks up on the 3 years of the annual reports. And let's see if it can figure out, because there was no performance. To provide a more accurate assessment, more context is required. Fair enough. And it manages to pick out sources as well for each of these years. Now what if we want to ask a more technical question? And so we say something like what is how has Tesla's gross margin changed over the past 3 years? And let's see. So now it figures out, I'm looking at these three reports. Increase, okay. Interesting. Nice. And you know, it provides references. So let's check the 2022 reference, page 39. Let's hop over. It usually covers more than one page, but let's see. Nice. So we got a comparison of the revenues, and it's able to kind of pick up on these things here as well. I think it mentioned some of these numbers pretty accurately too. So that's pretty cool. So that's what we're talking about here, is how do we talk across not just one, not just two, three or more PDF files to get insights. And so how does this work? Let's jump into the diagram. And before I do that, actually, if this is your first time kind of seeing this kind of structure I'm about to show you, it's going to be overwhelming. So I advise you watch the previous video that kind of covered a PDF chatbot, a simple PDF chatbot. And you can go to the repository here, and the link will be below as well. And this is the starting point for this. From here I kind of customized to design this demo that I'm showing. The demo is very buggy, so please, I'm probably not going to release the code anytime soon because I'm testing it as I'm recording this video. So here is the multiple PDF chatbot architecture. Now, if you've seen the previous one in the repo or the previous video, you're probably like, what is going on here? Okay, just bear with me. I'm going to go through this slowly. Okay, we're going to go through, make sense of what's going on. So first of all, we have the PDF docs of each PDF that you have. So in this case, I have, say, 2021 Tesla annual reports, 2022 Tesla annual reports. I convert each of them to text because PDF is binary, right? So you need it in text. And once we have the text, we split each of them into chunks because OpenAI has a context window that only allows so much. And so we have these chunks. We pass it to OpenAI to create these embeddings, which are just number representations. And this phase from here we'll call ingestion. It's the process of converting your docs into text and ultimately to number representations that computers can understand and you can store somewhere you can search for quickly. You can see that the 2022 got stored in these numbers here in this thing called a vector store, and 2021 the same thing. And what is a vector store? You can think of it as a database of some sort that houses the number representation of your documents in different categories or different spaces. And let's call these spaces namespaces. So a namespace you can kind of just think of as just a little box in your house, right? And that box has specific things. It could be a box that contains all your clothes, or it could be a box that contains all your shoes. The point is, it contains something similar. So in this case, this box, this namespace in this database contains the number representations of your PDF docs, but also the text of your PDF docs and any other quote-unquote metadata or information that's important related to your document. And the same thing for 2022. In this case, we're looking at Pinecone as a vector store, and we'll be using GPT-4. In this case, this is Ada, but we're going to jump GPT-4 and LangChain. We're going to jump into that in a second. So this is phase one. So you do this ingestion. Now here we go. Okay, so just follow it slowly. What was Tesla's gross profit margin in 2022? Now, the typical way would be you ask the question and we combine the question with the chat history. GPT will create a standalone question from these two. And then we convert those questions to numbers. And we go into the vector store. We specify a specific namespace or specific box that we want to retrieve from. And then we get the relevant docs. We combine the standalone question with the relevant docs, and GPT-4 looks at that context, question, the prompt, response. So that's in a nutshell how we've looked at things so far, right? But when you're dealing with multiple PDF files, right, you could technically, have standard question, vectors, 2021, which we did, right? Where you can ask an individual for individual namespace. You can say, specify the namespace and say, I want information relevant to 2021. I want information relevant to 2022. But what happens if you want to analyze things across multiple years, for example, or multiple namespaces? So you want to be able to say, I want to ask a question that is related to 2020, 2021, and 2022. And I want to analyze information that's cross-border. And so in that case, we need a new strategy. And so what was Tesla's gross profit margin in 2022? That's a straightforward question, right? So that would be a base case here, right? So if I just highlight this a second. But what if you ask, what was Tesla's gross profit margin in 2021 and 2022, right? So now you need a way to search 2021 and 2022 by first extracting the namespace from the question somehow. So we need to use GPT-4 to help us to somehow extract the namespace from the question. So in this case, if the namespace is called 2021, we ultimately don't want to hard code this. We want this to be dynamic. Does that make sense? I'll go over the code and kind of go through that slowly too. But you want the model to kind of figure out what year is the user referring to, what namespace is it associated with here, whatever name you've decided to give them. And then from there, we're able to have this dynamic relationship where we don't just hard code the namespace. We've got the namespace down here. And so when there's a question, we go convert the question to embeddings. But now we also have this context, this dynamic context specifying the namespaces to look at. We check the namespaces, 2021, 2022, retrieve the relevant docs for each namespace, and then we're back to the usual procedure. So that's why, if I go back to the demo, it's able to come back with something like this when I specify that I'm looking over the past 3 years. So if I say, for example, so this is a website called Seeking Alpha, used by a lot of investors. And so here it's saying revenue year on year. So let me ask, what is Tesla's estimated year on year over the past? Nah, let me just ask that. I think that should be sufficient. Yeah, revenue growth year on year. And so we ask the question. Let's see what happens. And so now it's going to ask to specify. So I'm going to specify what is Tesla's estimated revenue growth year on year 2022. And now we've specified, and now it's going to search 2022. So here we go. Let's see what it figures out. It's doing the calculations based on the consolidated statement of operations. It's dividing the numbers. And 51.33%. Let's see what Alpha has to say. I have no idea. No idea. Wow. That's crazy. Okay, I did not expect that to happen, but okay, interesting. And this is trailing as well, so this is accurate. So that's what happens. Now let's I just got a bit excited there. That's insane. Let's look at the code now. So I'll jump back to the join. I hope that makes sense what just happened now. It figured out the years, then attached it to the namespace. And so when the question was asked, it knew to draw the relevant docs from the two namespaces. Okay, so let's jump to the code now. Okay. Now, there's a lot going on here. So let me start from the beginning. So you can see in the reports folder, I have each Tesla PDF that I showed earlier. And I have a function, a script that I'm running called ingest data. And what ingest data does is it will go into the reports folder right here. Go use a directory loader from LangChain to read the file path. And as it goes through the file path, it's looking for PDFs, and it's going to load each PDF into text, right? And so I can kind of show you what that looks like. So we're going to do, let me just cross check. Oh, I've got other things going on. But let me show you what the output looked like anyway. So when you run this script, so I would have run the script, I would have done a npx tsx fig, and then had the scripts for scripts here, and ingest data.ts. So I'll cover more of this in the upcoming workshop. But effectively what this does is it loads this page. It checks the environment variable that contains the API keys. And then it also runs this, it compiles this to JavaScript from TypeScript on the fly as well, without having to emit the files, right? So if I was going to run this, it would read, but I don't want to do that because I've already done the ingestion and it took a couple of minutes. But once this process was done, let me just clear that before I get into trouble. this is what it looked like, right? So you can see I create a file, test.json, right? So this was the first phase, right? Where this is literally, you can see all, so 2020, and then you also have 2021 and 2022. And you can see this is all of Tesla's files in here. And what's good, the way I set things up was I have references to each of them, and that's why you saw the page number. So every page has a page number and also reference to the original source. So that was when you saw in the UI that it had that as well. And so if you see in ingest, in the ingest in test ingest, I also split them. So I split the, I basically created these dynamic namespaces, right? So the directory loads, as I showed in the diagram, you basically go through each folder, and then you create this grouping of all the different folders in a map. Again, a mapping of each year to a document. And I split them into chunks. I initialize it, so I haven't split yet. And then preparing Pinecone. So what's going on here effectively, again, I'm trying not to get into the details, more focused on a high level, is once we have translated the PDFs into text and we have grouped them, say, into different categories, so 2021, 2020, 2022, now we need to split them into chunks, right, as we spoke about. And so here I'm splitting into chunks of 1,000 and 200 overlap. And for each chunk, for each group, I am assigning a namespace, as we spoke about, called Tesla and the year. And so what you're going to see, what I did later on, was once I finished this phase one, in my config, I created a namespace years, right? And so 2020, Tesla 2020, 21, 22, and these are all associated with namespaces in my Pinecone account, which I'm going to show you in a second. So now we have, say, Tesla 2020. We split Tesla 2020 pages into chunks of 1,000 characters each. And what does that look like? Well, let me show you. So we split. You can see all of this is just 2020. Literally all 2020. And each one has the page number, right? Associated with the chunk. So this is page 5, page 5, page 5, page 6. And again, the date structure makes it easy to do searches and manipulation down the line. And so I did the same for 2021, 2022 as well. So then we have to kind of begin to put into this namespace. We're using Pinecone at this point, and we're trying to upsert into the namespace. But Pinecone has limits, right? So you cannot just do it all in one go. You have to do it in chunks. The recommendation is 100 vectors. So for context, again, remember your chunks are converted into embeddings. These embeddings are numbers, so you can call them vectors. So these vectors contain your numbers, representation of your pages, as well as your text and metadata as well. And so we need to split into chunks. So we split into chunks of 50 in this case. and each chunk is then inserted into the database, right? The Pinecone database. And this is all using LangChain functions to make it easier to run this process as well. So once this is all done, this is what it looks like. So let me hop back and kind of just show you. And so this is my Pinecone dashboard. And so once you sign up, you have all these variables here. Now, in the previous video, there was a lot of complaints about upserting, inserting. The thing with Pinecone is you have to be very specific. For example, your environment is kind of where is your pod closest to. And by default, if you're in a free plan, they will give you one. This has to match your environment variable in your code. Cosine is calculation done for similarity, and then dimensions is a number of dimensions that OpenAI creates. A dimension is, you can think of as one particular spot in an array of vectors. So if you have 0.1, 1.1, 1.2 representing your text, that's 3 dimensions. So when OpenAI does embeddings, it does 1536, so you have to specify 1536, otherwise the insertion is not going to work. You make sure your API keys are correct as well, and that your index name matches the index name of the configuration of the code. Again, I'm speaking more for everyone who had trouble with this repository, which I just want to thank you all for the support, because that's it's just trending on GitHub for a couple of days. So appreciate that. Now, where was I? Okay. So these are the indexes, the index info, and these are the namespaces. And if I jump, you can see Tesla 2020. These are number of vectors for each namespace. So remember, in the previous video, it was just 1. And now we have 3. And now we want to communicate across all 3 of them. So I hope at least this explains what's going on here. And in the previous video I showed, you can just come here and kind of play around. If you don't know what the vectors look like, it's pretty much a case of, if I click fetch, this is what a vector looks like. So you got your namespace, which is test in my case, and you can see this is the ID, and then you have values, as I said, which is just decimal, floating decimal number representations of your text. Because if I open here, you can see the text, right? It's the text. So the text is here, and these are the 1536 dimensions I spoke about, right? So let's go back to the code and see. So once this ingestion process is done, again, for anyone having trouble with this from the previous video, you just want to make sure that your config here, the namespaces are matching what's in your dashboard, and you've set your environment variable, right? Whatever that was. Other than that, don't tamper with the versions as well, because if you upgrade LangChain, there's some breaking changes. So just make sure you clone it exactly as it is, and you follow the instructions in the README, which I put there, and also you have the video you can check out as well. But anyway, come back to this particular video. So once the ingestion is done, now we want to go to the next phase. And so what's the next phase? Well, let me go back to the diagram, just in case you lost track. So we're done with this process. So now we want to move to phase 2. We want to chat. And we want to be able to specify, let me just drag that down. we want to be able to specify what exactly or what namespace that we want to retrieve information from. We want it to be dynamic. And so if I hop back, I think I have a script. So this is just like when I was trying to experiment with how to kind of go about this. And the way you want to think about it, again, these are all functions from LangChain and but kind of a bit customized. But this is just a high level. Let's think about this high level. So first you have your OpenAI instance. This is a LangChain OpenAI chat that basically has the same functionality as the API for OpenAI, except that it has extra features like caching and memory and stuff like that. So yeah, we want to think about on a high level. So on a high level, basically, we have the reports prompt. So basically, we just have some prompts that I wrote very quickly for this. And don't worry about the syntax. This is all LangChain trying to make life easier. Effectively, what we're trying to do is have these kind of human prompts with the system prompts, with the history, and we want to effectively be able to dialogue by calling the chain. So LangChain has these things called chains, which are just basically a sequence of prompts with LLM call to GPT, basically similar to the diagram we have. So don't be too intimidated by the stuff. I'll cover this in the workshop, upcoming workshop, and you can also look at the LangChain docs. Just focus on the high level and not too much on the code per se. And this is a function to extract the years from the query. And basically, the query is responding with a response that verifies, it says something like this, right? Or it could come back and say, like you saw in the UI, searching for whatever. And so based on that, you can extract the year using regex. And once you have the number, you map over the number, and then you're able to get the namespace, right? Because remember, we need to match the number to the namespace. In my case, this is the way I set up the date structure. It can be whatever you want to do. So if the AI says this question is related to 2020, 2021, then the function is going to return the two namespaces that already exist. So I hope that makes sense. And then you have this custom QA chain, and what it does effectively is that it takes the model, the index, the namespace. So the model is whatever your chat OpenAI or whatever your OpenAI API is. The index is here, so just Pinecone index, which is the LangChain JS fundamentals. And the namespace is whatever it pulled out. So basically, what this chain does is it's saying, go into the Pinecone, and effectively it's basically setting the stage for the phase that you saw in the diagram, where we have the standalone question, and then we're able to go with the standalone question to retrieve specific namespaces in the relevant docs, and then combine that and get a response. So this is all under the hood that's kind of happening. And this is a custom QA chain that I made, while LangChain has two others called Chat Vector DB QA chain and Vector DB QA chain. Again, don't get intimidated, but if you focus on the diagram, you realize it's not about the code. You can do it in other ways. This is just one way. And so I set chat history to nothing, and then we make the call, and we stringify, and we're good to go. So Let me show you what that looks like. So if I run, oops. MSC main.ts. I'm wondering if it's gonna complain about that. Is that sufficient? Cool. Let's see. So what I want to see is, okay, there was a question asked, I think at the very top, and we should see like GPT-4 trying to figure out what year you're referencing, extracting the namespace, and then we pass that namespace to the chain. And there we go. So it's beautiful. That's awesome, right? That's exactly what I was looking for. Because here we go. So search in 2021, 2022, we extract the now we extract the years, okay? Then we map the years to the namespaces that are in the vector base. We search the namespace for results. And then this is what we retrieved about risk factors included in the source document. So I hope this kind of demystifies what the UI was kind of doing by itself. And so basically, yeah, there's a front end. The front end is already on the repo, the GPT-4 PDF repo, so you can go use that. Really, this is just an adaptation. I'm just doing a ton of prompt engineering and just experimenting with talking across different PDFs, and then the chat where I basically use the same logic as main.ts that you saw, but I'm just doing it through the API effectively. So it's a similar logic. I just wanted to test it here first, and then once I saw this was decent, then I moved it over to the API, right? So that's basically it in a nutshell. I haven't tested it too much, but so far I'm able to read 3 different files with over close to 1,000 pages of in-depth financial analysis, and GPT-4 is able to do that and provide analysis across all 3 years that's decent. So let's jump back to the demo and see, have a bit more fun and see what's possible. So I'm going to use these guys because I think they have trailing. Oh, they have year on year. Okay, 3 years. Huh. Okay. Fingers crossed. Let's see. So let's pick one. Let me pick so revenue. Okay, compound annual rates for revenue over the past 3 years. Okay. Let's see what happens. Okay. I doubt this is going to work. Was the compound annual growth rate of Tesla's revenue over the past 3 years. If this doesn't work, I expect this not to work. All right. Okay, here we go. 1, 2, 3. So it's going to look at all 3 reports. It's going to think through that. Okay. 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 Okay, not bad. I mean, 50%, 60%. It's referencing the actual files itself. Wow. So this is page 49. That's interesting. Let's see. Let's ask one more question for the road. So you got profitability. What are the kind of questions? So we talked about risk factors, management, let's talk about growth rate. Based on the past 3 years, annual reports, what is the growth potential for Tesla over let's just stop there. Warren Buffett searching. Let's see. Wow. Yeah, this is incredible. I don't know how. So it's talking about, okay. So expanding production status. And for context, I've only set this to K1. So K1 is just the number of reference documents to return per PDF and use as context, and that's all I'm doing for now. I could actually increase the returned source documents as context, and I'm pretty sure the accuracy is going to jump. So this is a very rough sketch. If you're asking for the code, just go over here and kind of tweak and play around with it. But this is the architecture that you can kind of use for your own application. Like I said, it's just a case of thinking through this step by step and using GPT to help you along the way. So I'll also make some future changes to this repository as well. So I'll add features for multiple PDF files as well here at some point in the future. But in the meantime, if you have any questions, just shoot me a message on Twitter at Mayo Oshin, or you can shoot me a message on YouTube. I understand this is a bit complicated, but just kind of rewatch the video, and I'm sure it makes sense. So thanks for watching, and if you want more in-depth step-by-step details in this stuff, I'm going to be doing a series of workshops soon, so you can see that. Sign up for the waitlist in the description section as well. So that's it. Cheers.